So here's lesson 6.1. As you can see, I've already filled out the first page. So we're going to be looking at relations. We're going to be calculating the first differences, and we're going to be determining if it's a linear or non-linear relation. So you can see here I filled out the first chart related to this pattern of squares. So it's basically just calculating the perimeter of each pattern of squares. So how you would do that is you just count. Each one of these is 1 unit. So you find the perimeter. And we know the perimeter is if we measured all of the outside of a shape. So here we'd have 1, 2, 3, 4. So the perimeter would be 4. Here, for the next one, it would be 1, 2, 3, 4, 5, 6, 7, 8. So all we'd have to count is the number of units along the outside to get our perimeter. So this would be our perimeter in units. Next, we have to find out our first differences. So our first difference is basically calculated by, we can start at the bottom, and you just take the bottom number, take away the top number. So 24 take away 20 is 4. 20 take away 16 is 4. 16 take away 12 is 4. So we can see here, once we did that, we found all of the first differences. Okay, it says change in perimeter here, but that's the first difference. It's all 4. Okay, so it's all the same. It's always different by 4. Okay, next was to graph the relation. I graphed the relation, and what do we see? It looks like a line. So we can say, is the relation linear, non-linear? It's linear, right? We know that's called a linear graph or a linear relation. Okay, C, compare graph. So compare the graph to your first different results. So we can see if our first difference results are the same, so these are all the same because it's all 4, our graph is going to be linear. Okay, so here, write an equation for the perimeter in terms of the frame number. So what equation can we write? So if we have a frame number, we can always find the perimeter. And for this, it would be 4 times n. Okay, and I just write 4n because we know that's 4 times n. So no matter what the frame number is, if we multiply it by 4, we get our perimeter. Let's try that out. What's 1 times 4? 4. 2 times 4 is 8. 3 times 4 is 12. So we can see 6 times 4 is 24. Okay, so we see that we're right. Okay, next page. I filled in a bit from this page. So we're using that same square pattern. And this is the areas we should have got. 1, 3, 6, 10, 15, 21. So we can see slightly different pattern. Now we can again find our first differences. I'll start from the bottom. So 21 take away 15, we get 6. 15 take away 10, 5. 10 take away 6, 4. 6 take away 3 is 3, and 3 take away 1 is 2. So we can see our last one, the first difference was always the same as 4 every time. We can see in this one, it goes 2, 3, 4, 5, 6. So we can see the first differences are different. Okay, so now we have to graph this relation. So I'll just quickly draw it. Well, that's not going to work. I'm going to have to redo the scale. Go by 3 is 3, 6, 9. 15, 18. So this will work because we can see a lot of the numbers are multiples of 3, right? So frame number is 1. 1 would be about here. And frame number is 2. Our area is 3. Frame number is 3. Our area is 6. Frame number is 4. The area is 10. Frame number 5 is 15. Frame number 6 is 21. So 21 is right up here. So let's see, can we connect this? We can't draw a straight line here, so we know it's going to be a curved line. Okay, so is the relation linear or non-linear? Non-linear, because it's not a straight line like our last one. Okay, so compare the graph to our first difference results. Okay, our first difference is we're always different. 2, then 3, then 4, then 5, then 6. So if we see that the first differences are different, it's nonlinear. Okay? Formula, area equals 1/2 times n squared plus n can be determined. We have to check our data using this formula. So let's do it. Let's try with any number. We'll try with 2. Okay? So area equals 1/2 times 2 squared plus 2. So we gotta do our brackets first. So 2 squared is 4 plus 2 is gonna be 6. So we have to do 1/2 times 6, which is just gonna be half of 6, which is 3. So we used 2 and we got 3. Okay, you know what? It's right. You know, I don't need to check again. I know that this is right. Okay, so conclusions. Based on the above 2 examples, we should be able to conclude the following. If the first difference of our relations are constant, okay, so if it's the same, this is linear. The first difference of the relations are not constant, not the same, so like our one up here, it's going to be, sorry, I'll move it up a bit, non-linear. Okay, hopefully that makes sense. Let's see, one more page for this. So we have a new square pattern. Okay, now we're talking shaded squares and unshaded squares. So our first one is shaded squares. So each frame number, I've already filled in this chart, number of shaded ones. So we can see 2, 3, 4, 5. We know it's going to follow the same pattern for the last one. It's 6. Okay, let's do our first differences. 6 minus 5 is 1. 5 minus 4 is 1. Okay, so it's all 1. Okay, we know it's constant, so it's linear. Okay, let's look at our next one. So, number of unshaded. So unshaded in the first one is 1, then 3, and then 6, and then 10, and then, you know what? I know it's going to be 15, because it increased by 2, then 3, then 4, then 5. Okay, let's do our second differences. 15 take away 10, 5. So, you can see our second differences are not constant. So we know it's going to be nonlinear. We had to write an equation for these, so I already did that. Our equation for the shaded ones is our frame number plus 1. So if our frame number is 1, we add 1. That's 2. 2 plus 1 is 3. So we can see easily that this is correct. Whatever our frame number is, we add 1 to it. Sorry, I didn't know you couldn't see that. So our frame number plus 1 will give us our shaded squares. Okay, and our formula for the second one's a little bit tougher. It's our frame number multiplied by our frame number plus 1 divided by 2. So we can quickly just try that. So our frame number here is 1. So 1 times 1 plus 1, which is 2. So 1 times 2 is 2, divided by 2 is 1. Okay, we got it. 2 times 2 plus 1 is 3, so 2 times 3 is 6, divided by 2 is 3. So that would be our equation. So that was a little different, or more difficult to figure out. Okay, here, our last one, again, I have the charts filled out already. Number of shaded circles, you just have to count, right? First one is 4, next one is 6, next one is 8. We can see it's following a pattern, so we can fill in the next 2 easily. First differences, let's see it. We can see 12 minus 10 is 2, 10 minus 8 is 2, so it's 2 for all of them. It's constant, so it's linear. Next one, we can see, okay, total number of circles, so 5, 8, 11, so we can see it's all increasing by 3 each time, so these ones will as well. 17 minus 14 is 3, okay, 3. It's constant again, it's linear. Okay, so write an equation for the shaded circles. So shaded circles, you know what? It's always increasing by 2. We'll do 2n plus 2, okay? 2 times our number, so 2 times 1 is 2, plus 2 is 4. 2 times 2 plus 2 is 6. 2 times 3 is 6, plus 2 is 8. So that's our proper one. Okay, and then now we have to write an equation for the total number of circles in this pattern. So let's see. It's always increasing by 3, so we know there's going to be a 3 in there somewhere. So let's do 3n plus 2. 3 times 1 is 3, plus 2 is 5. 3 times 2 is 6, plus 2 is 8. 3 times 3 is 9, plus 2 is 11. 4 times 3 is 12, plus 2 is 14. Okay, so that's correct. Okay, hopefully everything here made sense. If you have any questions, let me know.